All right, for the second part of section 5.4 of completing the square, we are going to now solve quadratic equations by completing the square. So I taught you how to add that or figure out what the b over 2 squared was the last couple of days, and now we're going to move farther with that and actually solve the equation. So there's 6 steps here. I am going to do example 3 as I walk through each step. So step number 1 says collect variable terms on one side of the equation and constants on the other. So what that means is, for instance here, I have 27 minus 6x on one side. I want that 27 by itself. I want all the variables on one side together. So what I'm going to do is add 6x to both sides. So I have x squared plus 6x equals 27. So that's step number 1. Then if we go back up here, step number 2 says as needed, so we don't always have to do this, divide both sides of the equation by the a value to make the coefficient of the x squared term 1. So what that means is if we had, let's say we had a 5 out here in front of x squared, we would have to divide everything in that equation by 5. We don't have that number. That's why step 2 says as needed. We don't have to do it in this case. All right, so we're going to move on to step 3. It says complete the square by adding b over 2 squared to both sides of our equation. So change color here. Step 2. We have to figure out what b over 2 squared is. Remember, b is in the coefficient in front of just the regular x. So we're going to have 6 over 2 squared, which would be 3 squared, which is 9. So it said to add that to both sides of our equation. So I'm going to have x squared plus 6x plus 9. And then on the other side, I'm going to have 27 plus 9, which is 36. So that's step 3. Then step 4 says factor the variable expression as a perfect square. So this step 3, we are going to factor this. X times x, or x squared is x times x. Square root of 9 is 3. Remember to double check. We do 2 times, one of the front, one of the back. So 2 times x times 3 is 6x. It's all addition. So we factored it. We have x plus 3 squared, because both sets of parentheses would be x and 3, equals 36. Then step 4 says, oh, that was step 4. Step 5, take the square root of both sides of the equation. So I got off on my steps here because we didn't do step 2. It said as needed. So really this red is 3 and the blue is 4, step 4. All right, now step 5. Step 5, we are going to take the square root of both sides. So when I take the square root of x plus 3 squared, I'm going to be left with x plus 3. And the square root of 36 is positive and negative 36. Step 6 is to solve for the values of the variable. So now we are going to divide this up into 2 equations. We have x plus 3 equals a positive 36, and we have x plus 3 equals a negative 36. And I just realized I totally messed this up. So let's go back and actually take the square root of 36 and put 6 there. And now let's solve these by subtracting 3 from both sides. So x equals 6 minus 3 is 3. Minus 3 from both sides, x equals negative 9. So those are our 2 answers for this problem. For part B, this one has a coefficient, so I'm going to show you how to do that now. All right, so step one, collect all the variables on one side and the constant on the other. That part is already done here. Step two is to get rid of the coefficient, the a value, so the coefficient of x squared, which we have a 2 here. So I'm going to divide everything by 2. So I'm taking out a 2. I would be left with x squared, 4x, and 6. Then step 3 is to complete the square by adding b over 2 squared to both sides. So b over 2 squared. B in this case is a 4, so 4 over 2, and then square that. So that's 2 squared, which would equal 4. So we're going to add 4 to both sides. So we're going to have this 2. We're going to have x squared plus 4x plus 4. And then on this side, we're going to have 6 plus 4, so we're going to have a 10. All right. Now we factor what's inside of the parentheses. So that's x times x, and 4, the square root is 2 and 2. So again, double check 2 times 1 of the front times 1 of the back. So that would give us 4x, so we're good. We have a positive x and we have a positive 2, and there's 2 of those, so squared equals 10, and I can't forget that 2 out front. And then, now that we have this, we are going to take the square root of both sides, and I am going to ignore that 2 right now. When I take the square root, it cancels out the squared, so I have x plus 2. And the square root of 10, we can just write positive or negative square root of 10 since it's not a perfect square. And since it's not a perfect square, I'm not going to divide this up into 2 different problems. We're just going to leave it as a square root of 10. It makes it easier. I'm going to subtract 2. And remember from before, I said I don't want to write minus 2 after the radical because it might look like that minus 2 is under the radical, and we want to make sure it's known that it's out front. So negative 2, and then plus or minus square root of 10 is the solution to that. Now example 4 is to write this in vertex form and identify its vertex. So we're given a function, which in this case is x squared plus 10x minus 13. Now this is not a perfect square trinomial, so I'm going to kind of break it up so that we can complete the square so we can make it a perfect square trinomial. So what I'm going to do is we're going to write x squared plus 10x, and then we're going to leave a spot here where we're going to add the square that we find, the b over 2 squared. And then I'm going to move that minus 13 behind that. So I'm going to add my b over 2 squared here, and I'm going to subtract it here. Because if I add it in one spot and subtract it in another, it kind of cancels itself out. So next is to find the b over 2 squared. B is 10. I forgot to write the x there. 10 over 2 squared, and 10 over 2 is 5, so 5 squared is 25. So we're going to write 25 here. And I want to keep these terms together, and then I'm going to simplify these terms back here. So when I factor the trinomial here, so now I'm looking at this part. When I factor that, the x, let me rewrite it so I have room, maybe that'll help. The x squared is x times x, and the 25 is 5 times 5, and everything's positive. So this is x minus 5 or plus 5 squared. And then I have to simplify this, the negative 13 minus 25. So that makes a negative 35. 8. And this was called f of x. And now it is in vertex form. And remember, vertex form is h minus k. Oops, x minus h plus k. And if you remember from quite some time ago, our vertex is hk. So if we look, the formula is minus. We have a positive 5 in that spot. So that must have meant we plugged in a negative 5. So our h is negative 5, and our k here is negative 38 because it says minus 38. So the vertex, which is what they asked us to find, put it in vertex form and then find the actual vertex. So that's negative 5, 38. Negative 5, negative 38. Now for this last one, we're going to split it up again. So I have 2x squared minus 8x plus our square, and then I'm going to move that plus 3 out, and I'm going to minus our square. So we have a 2 in common here, so I'm going to divide out a 2. So I have x squared minus 4x plus our square, and then we have plus 3 minus our square. Now we have to do b, which is negative 4 over 2 squared. So that would be negative 2 squared, which would be 4. So I'm going to add 4 here, and we're going to subtract 4 here. But since we're multiplying by 2 out here, we have to multiply by 2 here. So whenever we factor out a number, so if I factored out a 3 there, right here, then I would have had to put a 3 right here. So whatever number you factor out in the front, you have to add back there. So now I am going to I'm going to factor what's in the parentheses. So the x squared minus 4x plus 4. That's x and x, 2 and 2. But now I notice this is a negative, so these two 2's have to be negative. So factored, it would be x minus 2 squared. And then when I simplify the back part, I have 3 minus 2 times 4. So that's 3 minus 8. That's a negative 5. And also I have to bring out that 2 from the beginning and add that there. So now that is in vertex form. And remember, we have x minus h plus k here. And the vertex is the h comma k. So h, our generic here is a minus h. In our equation that we found was a minus 2. So h is just a regular 2. And then k is positive, and we figured it out to be a minus 5, so it's a negative 5 here. So the vertex of this parabola is 2, negative 5.